Several years ago, Heroku put out a methodology for building apps called the 12-Factor app. I'm going to be putting out a series of videos on how to build a 12-Factor Drupal app using Docker, with a brief demo to illustrate each point. My name is Tom Friedhoff. Welcome to the first video of the series. Today I'll cover Factor 1, one codebase, many deploys, and touch on Factor 10, the dev prod parity concept. I'll demo how to set up a Drupal development environment using Docker, Docker Sync, and Docker Compose. What's up, Internet? Let's talk a little bit about Factor 1. It's actually kind of hard not to build a 12-factor app when using Docker. Docker, or containerization in general, lends itself really well to the 12-factor process. Factor 1 states, one codebase tracked in revision control, many deploys. In my opinion, the number one reason for using Docker is deployments. Specifically, the parity of all the deployments of your app, which is one part of Factor 10, the dev prod parity concept. Typically, when you hear the word deployment, you think of dev, stage, or the prod environment in some cloud platform that you deploy to. But as factor number 1 of the 12-factor app says, a deploy is any running instance of the app. Every developer has a copy of the app running locally, each of which also qualifies as a deploy. The essence of this factor is that your app code base should be kept in a code repository like Git, and that every deploy or environment that runs your app pulls the code base from the same code repository. So where does Docker play into this? Docker is infrastructure, right? Well, if you've been following any of our blogs or are subscribed to our YouTube channel, you know that we're huge proponents for infrastructure as code. Our view is that the infrastructure necessary to run an application is part of the application and should be in the same code repository as the application codebase. We've been doing this for years with Vagrant and provisioners such as Chef, Puppet, and Ansible, and we've talked about it in our blog. Well, with Docker coming on the scene, our process has improved once again, making packaging apps much easier to manage and share across separate deployments. Why is it a good idea to consider infrastructure as part of your application? Have you ever run into the situation with one of your coworkers, or even worse, with one of your clients saying, well, it works on my machine? 12-factor calls this the tools gap. You can read more about that in Factor 10. Apps can behave differently on different technology stacks. For example, using nginx in production, but developing on Apache locally. Or MySQL in production and SQLite locally. You run the risk of bugs that only exist in one environment, which are hard bugs to debug. Having all your deployment environments practically identical prevents these issues from happening. I say practically because when your app is deployed to production, the environment might be slightly different. For example, deploying to a cluster of machines instead of a single machine. These, well, it works on my machine issues can even happen across your team as well, across your local environments. Developers using different operating systems locally create disparity. Developers on OS X may not have all the packages to run an app that exist on a developer's machine using Linux. And if you're on Windows, good luck. What do you do there? I'll give you a hint. Install Docker. The disparity doesn't end with different technology platforms. What about specific versions of technology? For example, running PHP 7.1 on production, but your local environment is running PHP 5.6. In that scenario, you'll most likely run into problems once you deploy to the production environment. There are break and changes between those two versions of PHP. That's why it's so important to package your infrastructure with your app, so that your app can run with the smallest tools gap as possible between environments, whether that be your individual developer machines or your dev, stage, and prod servers. Let's hop into a demo. I'm going to take you through setting up a local development environment with Docker, Docker Sync, and Docker Compose. We'll start to set up Drupal as a 12-factor app. All right, so let's go ahead and get our local environment set up. If you want to follow along at home, I've got this GitHub repository. It's a public repository. You can find it at this URL. But this has basically got all of our Docker config to get a local environment set up locally. So I'm going to clone this repository. Grab this URL here and clone that out to my current directory. All right, so let's open up this code base and see what we have. We're going to go into the Docker Compose file first, since that's where most of the magic is happening. This Docker Compose file basically describes all the containers that we want to have in our app. And so you can see right here, we have a MariaDB container. We have a PHP container. If I scroll down, we have an nginx container. And that's it. We have 3 containers in this Docker Compose file. And specifically, we're using images. We don't have a Docker file in our app yet. We'll eventually put a Docker file in there because we're going to customize some of these images. But initially, for this first video, we're just going to pull the default images straight from Docker Hub. So you can see we're pulling the MariaDB image directly from Docker Hub here. And then the PHP container is actually using the Drupal image, the 8.3 FPM image. And if we scroll down, nginx is using the nginx latest image. And so all these images are found on Docker Hub. And so if we were to open up Docker Hub and type in Drupal, you'll see the official Drupal images here. And we're specifically pulling down 8.3-FPM, so we're pulling down this version of the image from Docker Hub. And so if you want to look at the details of what that includes, you can go to their Docker file and see what exactly is being pulled in. All right, so we also have a Docker Compose dev file, and this file is actually introduced because we're using a technology called Docker Sync. And so if we do a quick Google search for Docker Sync, there's a really cool library out there called Docker Sync that basically sets up sync containers so that you can have your code that's on your local machine actually run natively within a Docker container. And so Docker Sync is what does this magic. We're specifically going to be using a sync strategy called native OS X. And what's really cool about this Docker Sync process is that there's two-way sync going on here. We're essentially declaring to Docker Sync that everything in our source web profiles directory, so if we open up this directory, source web profiles, so essentially this active LAMP profile here will be synced down to a Docker container. And now with Docker Compose, we can basically specify volumes to share within a specific container. And so this Docker Compose dev file will basically define a volume on our PHP container saying use the Drupal sync container and mount the Drupal sync container at this path inside of the PHP container. And so this Drupal sync volume is actually created externally from Docker Compose. It's created with this Docker sync YAML file. So this Docker Sync YAML file actually creates a new container inside of Docker which just holds your synced files. So when we end up starting our stack, what you'll see happen is a sync container will start and all the files from this directory will get synced into that container. And then what will happen is our Docker images will get downloaded and the containers will get started for that. And this PHP container, we're going to mount a volume, which is that Docker Sync container here. So our source web profiles directory will get actually mounted into the PHP container. And so let me actually boot this up and show you how that works. Before I do, I'm going to show you guys this makefile. All of our projects, we have it's common for us to put a makefile in the root of the repository so that new developers that are coming on board can see the common commands that they need to run to actually set up the installation. And so typically, if we were actually doing a build with like a Docker file, typically you'd have to run this make setup build, because what that'll do is actually build the Docker containers or build the Docker images that we need for this application. But for this particular application, we don't have any Docker files. We're using the stock images that we're getting from Docker Hub. So in this case, we're just going to run make setup. And what make setup will do is it'll actually run a bundle install. And bundle install is basically just running this command right here. You'll see that we have Docker sync specified in a jump file. So basically Docker sync will get installed when we run make setup. And then if we had any images up on Docker Hub, which we do, we have the 3 images that we defined here, the MariaDB, the Drupal FPM, and the nginx. The pull images command will actually pull those images down. So it's just running a Docker compose pull here. And then the last thing that we do is pull dependencies. And I'm not going to cover that in this video, but in a future video, you'll see what pull dependencies actually does. And so I'm going to run this command and start to set up this environment. So you can see it's installing Docker sync, all of the Ruby dependencies to run Docker sync, and now it's pulling down the Docker images from Docker Hub. All right, so now we have all the images from Docker Hub. The next command that we want to actually run is this make start command. And so what make start will do is this is going to start the sync stack, and it'll essentially boot up all of the containers that we've defined in our Docker Compose. It'll also read in this Docker Compose dev file, so our local containers will have this Drupal sync directory, and it'll boot up this sync container as well that has all of our files in it. So let's boot that up really quick. And typically with these projects, we have a README file at the root of the project so that new developers see the commands that they need to execute to spin up these environments. You can see here that it spun up several containers. We have a PHP container that's spun up there. We have a MariaDB container. You can actually see that it spun up an nginx container as well. And right above that, we have this sync log. And this is where Docker sync comes into play. Basically, what happened is the files in the directory that we specified, this source web files directory, is going to get synced to a Docker container. And so let's take a look at all of the Docker containers that we currently have running. I'm going to open up a new terminal here and run docker ps. And let's make this a little bit smaller so we can see this all in one line. Be a little bit easier to read. So you can see here that we have 4 containers set up. So we have the 3 containers that we defined in our Docker Compose file, and then we have the 1 Docker Sync container down here. Let's jump into the Docker Sync container that we named Drupal Sync and see what that looks like. So I'm going to execute an interactive shell and run bash. And so now I'm actually in this Docker Sync container. If I ls this, you're going to see that I have a directory called AppSync, and I have another directory called HostSync. Now you can go read the docs of Docker Sync to see how this actually works, but with the sync strategy that we're using, we basically have Mac OS writing to this HostSync directory, and then inside of this sync container, there's a 2-way syncing technology called Unison that's syncing from HostSync to AppSync. And AppSync is what is actually mounted on the other containers that we're adding the Docker Sync volume to. And so if I go into AppSync and look at this, you can see there's that active lamp directory that we were talking about. And so let me just move over here. You can see in the active lamp directory, we have config modules and this info file. So let's ls that directory, and sure enough, we have the info file, config, and modules. All right, let's jump out of this container and look at our containers again. We also have this nginx container here. I'm going to jump into that in a second, but before I do, let me show you our Docker Compose file again. For our nginx container, we mounted a couple volumes. We mounted a Drupal install volume at var www html. And the reason why we mounted this Drupal install volume is because that Drupal install volume actually comes from this PHP container, which is the Drupal Docker image from Docker Hub. And so by specifying a named volume, we're able to share this volume from the PHP container with nginx, so that when you visit var www html on the nginx container, it's actually going to hit the volume that's shared over on the PHP container. One other thing you'll notice here is that we're taking this site.conf file. So if we open this site.conf file here, we're moving into the conf.d directory and naming it default.conf. And so essentially what we're doing is we're taking this configuration file and making that the default configuration of the nginx server. Before we jump into the nginx server, you'll notice that we've configured this to work with Drupal. Essentially what we're saying is for every path, basically look for the index.php file in Drupal and pass the URI as the queue parameter on the index.php path. And then we're also specifying that any files that have a PHP extension, pass this off to the PHP container on port 9000. Because this nginx server doesn't actually have PHP installed on it, we're going to a separate container that does have PHP FPM installed, and so nginx is basically just passing off all that traffic to the PHP container. This PHP alias right here coincides with the names of our services, and so if we named this Drupal, then in our site.conf file we'd have to name this Drupal as well. And so these Docker containers inside the Docker host can talk to each other based off of these container alias names. All right, so let's jump in to the nginx container just to make sure that everything I said happened. And so we're going to execute an interactive terminal, and we're going to say, I'm going to use the hash, so 6c73 bash. And so I'm going to go into the nginx container conf.d directory. There's our default configuration. If I cat that out to the terminal, you'll see there's the file that we have in our local code base. All right, and the last thing that I want to do before we actually see this application working is I want to log into the Drupal container. And so this is, again, these containers are writing straight up images from Docker Hub, and so you're going to see what Docker Hub basically gives us, or what these images give us from Docker Hub. So I'm going to go into this container here. And so now I'm inside of the Drupal container, and if I ls this, you can see that we have a fresh install of Drupal 8. This was packaged inside of the Docker image that we grabbed from Docker Hub. One change that you will see in here is if I go into this profiles directory, you'll see this active lamp directory. And so again, this is happening because we mounted the Docker sync container to that path. And so if I come over here to the Docker compose dev directory, you can see on the PHP container, I'm mounting a volume called Drupal sync to this specific path within that container. And again, this Drupal sync is defined by this Docker container mentioned in the Docker sync file. All right, so let's hit this app in the browser. As you can see on this nginx container, I'm exposing port 7080, and that's mapping to port 80. So let's hit 7080 in our browser. Pull this up. And there you go. We have this installer, we're actually installing the ActiveLamp profile, and the reason why that is if we open up our activelamp.info file, you can see that we named this as a distribution. I essentially copied the standard profile and then named it ActiveLamp and called it a distribution, and Drupal is basically going to respect that and say we're installing the ActiveLamp distribution. So let's go ahead and run through this installer. And we'll configure our site. And there is our local installation of our ActiveLamp profile. Now if we head over to the modules page, I have a module in here called 12-Factor. And so you can see that it's automatically enabled because we mentioned that as a dependency of this profile. So as you can see, we have code on our local machine that's getting synced into a Docker container, and we're able to make modifications and see those changes in the Docker container. So if I go into this modules directory, and let's add a module file here, 12factor.module. This will get automatically synced into our Docker container. If we come over here, we'll actually see it get synced over here. And scroll down, you can see that it actually synced that file over. And if we jump into that Docker container, so let's, I was already in that container. Let's go into Profiles, ActiveLamp, Modules, 12-Factor. And ls, you can see there's our 12factor.module file in our Docker container. And if I were to, there's no VI on here, but if I echo some content into that, hello world, I've just added hello world into that module file inside of our container. With the magic of Docker Sync, we should see that synchronization come back up to our local machine. And so there you see it, hello world there. And so this is one way of shipping your infrastructure with your actual application code. Now every developer that checks out this repository has an identical environment as the next developer. And in a best case scenario, these Docker containers are what you're actually deploying to production. We're just barely scratching the surface with this 12-factor app. To recap what I've shown you, our application code is in the same repository as the infrastructure code to run this application. As more dependencies on infrastructure become a requirement, for example, if we introduced a Redis cache, we have an easy way to define that in our Docker Compose file and share that with all the other developers on this project. By the way, dependency management is actually the topic for our next video. We'll talk more about that next time. Make sure you subscribe to our channel to get notified. All of the individual deploys of this application not only have the same code base, but also the same infrastructure that the app runs on, all managed in revision control. This approach truly fulfills factor one of the 12-factor app. That's all I've got for you today. If you liked this video, make sure to give us a thumbs up and subscribe to our channel if you haven't already. See you next time.